Question number 15b, we are having to solve the differential equation. We have x's and y, so we're going to have to separate and integrate this. And we also been given an initial condition which allows us to solve for c. Okay, so we can get a specific solution to this differential equation. So the first thing I'm going to do is I'm going to split up factor my x out of the square root, because when I do that, I'm just going to do it like this. So my dx is on bottom, and I have dy on top. And when I factor the square root x out, I now have my expression so that I can actually separate it by multiplication and division. So this allows me to separate my dy with y's, dx's with x's. So I end up with dy over 1 minus y squared, square root, and on this side I end up with square root x and dx. I'm going to integrate both sides of this, and on the right hand side I just have a standard integral power rule. On the left hand side I have to recognize that this is an arc sine antiderivative. So I end up with arc sine of y, and then we have our plus c. I'm going to put the plus c at the end. The square root, okay, becomes x to the power 3 over 2 to divide by 3 over 2, which ends up looking like that. And then I have to make sure I have my plus c, which I will solve for in this case. Now, it's really important to recognize that this is not some standard power rule. This cannot be done with a power, it cannot be done with a substitution. We have to recognize it is an arc sine antiderivative. Okay, so at this point here, we should maybe plug in our value. We're going to plug in this value and then solve for the plus c. So I end up with the arc sine, and I have over here just my power, so 2 over 3 to the power 3 over 2, and then we're going to solve for our plus c, and we're going to do that by substituting in x is 0 and y is negative 1. Okay, so the arc sine of negative 1, so sine is vertical, so it's at the bottom of the circle, so that's going to end up being negative pi over 2. 0 is just going to be 0 plus c, so the c works out to be minus pi over 2. So once I've solved for c, I can put this back into my original equation. So here's my solution, my general solution. So I'm going to plug that back in. The arc sine of y is equal to 2 over 3 x to the power 3 over 2. In this case, it's plus c is going to be minus pi over 2. And then I can solve for y. Y is equal to, I undo this arc sine with sine, and it's going to be the sine of whatever this angle is in here. So there's the specific solution to that differential equation problem.